Welcome back to my PythonNet series. The main goal of this video is to help you extract errors from PythonNet. In this video, I'll be extending the SnakeHospital demo from the first video to show how you can handle errors in PythonNet. If you haven't seen my first PythonNet video, the link is in the description at the bottom. In order to have context on what I'll be showing you, I encourage you to watch that video. Let me show you what we'll be working on today. Here's a quick preview. Our SnakeHospital demo from the first Python video was extended to include an interactive section here where we can basically interact with Python directly. So if we wanted to print a version of Python, we could, or if we wanted to get errors from Python, we could also do that. The basic idea is to interactively build our programs instead of putting them all at once in one file. So anything that we type here should work in our script. So let's get started. So if you're new to integrating PythonNet into .NET applications, you will inevitably run into errors. Hopefully, by the end of this video, with the topics that I discuss, it will make your life a little bit easier. So for today's topic, we'll discuss standard input, output, and error. The REPL window, which I showed you in the beginning, will be coding in C# and a little bit of WPF. Hopefully it's not going to be too much, but let's see. Debugging Python code with Visual Studio. So that's going to be interesting because we are going to be able to see the stack trace and also step into Python code, which is also pretty cool. So let's discuss standard input, output, and error. So the PythonNet documentation is a little bit unclear, and they don't explain to the extent that I would like them to explain how error handling should be done. Basically, standard errors are thrown as Python exceptions, and I find that a little bit inconsistent because it's capturing standard output, it then has to be done manually. And currently, there is no way to capture standard outputs via PythonNet easily. So what you have to do instead is create a C# object which has the close, flush, and write lines methods. Basically, inject those into Python, and then you can capture Python outputs with your .NET object. It sounds confusing, but it works, and I'll show you that in a bit. The REPL window. So REPL, first of all, stands for Run, Evaluate, Print, and Loop. It's basically our interactive Python shell. So what the goal is now is to emulate this Python shell in our WPF application. So if I wanted to simply print out and capture the standard output, our application should be able to do that, or also as well the standard error. So in order to make that happen, I'm going to do the bottom-up approach first. In our application, we have a PythonNet engine, which is a wrapper to PythonNet itself. All commands are piped through this Python engine wrapper, and then the Python engine controller, which is right above it, is the coordinator between the user interface and the Python engine. And finally, the user interface at the very top is where the REPL window itself will be located. And there's going to be some XAML involved as well here, C# obviously, and some Python as well. At the end, of course, we should be able to capture the outputs and errors in our new REPL window. So let's get started. So let's get to the coding. As I'm going to be coding here, I might be going a little bit fast. So everything that I'm doing here is available in GitHub. I do encourage you to check out the source and play around with the example. I think that's the best way to learn what's going on here. As I was mentioning earlier, we do want to override these methods so that we can capture the output from Python itself. In order to do that, let's begin by writing a simple logging interface so that Python can write to our custom object, and once it does that, we can capture what we need to. So let's begin by adding some sort of logger, because that's what we really need. So we need an Python logger. It's going to be a very simple interface. So let's first make that public. What we need to do is override these 4 methods I mentioned earlier. And this is going to be the first thing is going to be the flush method. And do make sure that the methods that you write are all in lowercase, because that's what Python expects it to. The next method is the method. And this one has 2 variations. One is the right and right lines, I believe. But we'll see. I think it's right and right lines. So, and then the other one is right lines. So this one is a bit different. I think it's strings. And the last method we want to write is close. So let's do that. Close. Now, what Python is going to do with our custom object is it's every time it needs to write something, it's going to call this method, right? So we have data that Python is writing into our object, but we need a way of retrieving it. So let's just retrieve it as a string. We'll call it, let's just call it read string. Now we have a way of retrieving the data that Python has written to our object. And that's pretty much it for the interface. So now let's move into the implementation. So let's now write the implementation of our Python logger interface. Let's first add a folder. We'll call it logger. Here we'll add a class. We'll call it Python logger. Of course, we'll inherit from our IPython logger interface. We'll implement the methods. And of course, we'll say this class is a public. So for this class, we want to capture the output of Python, and we have to capture it somewhere. So let's make a buffer. This is going to be as easy as a list of strings. Let's just say that. You can obviously optimize this in any way you want, but I think I'm just going to keep it simple and just say list of strings. So buffer, and that's our buffer. Flush. Flush is going to be easy. Basically, when Python calls flush, because we are doing this for Python, so that Python can call the flush right and right lines, and close, of course. But we are going to be calling read string. So for flush, we'll just say buffer.clear. That's all we need to do. For write, so we have to write to our buffer. In this case, we are provided a string by Python. This is going to be from the standard output. So what we need to do is just simply take string and put it in buffer. That's as easy as mbuffer.add and then str. So that's it. And then we can, I think it's also useful to, why not, just trace right lines 0. So that's it. So I just want to see this when we're debugging. I just want to see it in the output console. So for our right line methods, yeah, so this is going to be also simple. We'll just take our buffer and then we say add range. Provide the strings that we want to add. Yeah, that's it. For close, we don't actually have to do much here, but I'm just gonna clear my buffer when it closes. You can do something else yourself here if you want. Read string. So this is for us. This is what C# is going to request whenever we want to write the output of Python. So for that, I want my output, it would be nice to have it in different lines. So for every item in the list, I want to have it in a new line. So let's just say we go string dot. Let's just join the let's join a new line per item, and this is an easy way of doing it. So that's it, and then we'll return that as string. yeah, that's it. Let's build. Make sure it builds. It does build, and I have it as release, which I don't want as release right now. So let's build. Let's debug. That's it. We do have one more thing to do. We do have to register this new created type. So let's go ahead and do that. We'll go to builder, register. And we're doing this because we're going to inject it. Register type, Python logger, this guy, and we'll register it as an instance as well. Instance per lifetime scope. And this is an Python logger. And we have to tell it we want an instance per lifetime scope. So basically, when we in our scope where all of our objects live, we'll get a Python logger, one Python logger per instance. Now that we have our implementation of our logger, let's inject it into the Python engine that we have. Python, let's just create a backend code for that. We do now want to inject this into Python, so let's have a method that does that for us. Initialize logger. Let's just call it that, and then let's create a method. Great. Now, I do have a pre-built method called setVariable, which given a name and .NET object, it's going to put that into Python memory. So it's going to convert that to Python and then set it in somewhere in memory. So pretty simple. So let's go ahead and reuse that. For that, I'm just going to go and say setVariable. The name of our variable, I'm just going to call it logger. And then for that, we have our Python logger, which we already have. That's it. The next thing is to build a Python source code to actually inject this logger, which we already have in memory, into our standard output and error. So let's do that. Logger source. And first things we're going to do is going to import the sys. And we're going to do this in multiple lines. So next is the IO, and then I want to import string IO. And the next line then is the interesting line. So let's say we want to replace stdout. So stdout is going to now take the place of our logger that we put into Python memory, which is our logger, so that we created. Right. So that's it. That's it. Let's do that in multiple lines. But we're not done here because we also want to do the standard error. But also we want to do a sys.stdout.flush just to get rid of stuff if there's something there already. Right, so next up is the std error. So from sys.std_error equals logger. So that's it. And then we also want to do a flush on that. So sys.std_error.flush. That's all we have to do, and of course we do have to execute this command and say logger source. Great, now we're done. Let me just double check I didn't make any silly mistakes. That looks good. If not, I'm sure we can figure it out. Okay. Next is we have to modify the execute command a bit to basically read from the output of either the exception or the output of Python. So yeah, let's go ahead and do that. So when we execute a command, we need to also read its output from either the exception or the Python standard output. So let's just do an logger at that point when we finish executing, and then we say read stream. So whatever Python has put into the logger at that point, we'll read it and we'll report that as the result. Okay, And we also want to do a logger flush at that point. We do not want to keep everything there forever, so after every command we'll flush that. The next thing to do is to edit our main window. We want to add a place where we can see the output of Python and also give Python some commands. In our application, and let's run it to make sure we didn't break anything. Everything seems fine, so let's also run this script, which is going to create a histogram of the age, generated by Python, or matplotlib to be exact. Let's begin and edit this. Now, I think the first row should be the, yes, so that is the title, and the second row is everything else. Let's begin by adding a new row, and we have it down here. The problem with that is I think it's too big, so let's restrict that to 150 pixels. That seems about right. Now let's add another grid down here, and that is where our output is going to go to for Python. There we go, and it put it as row 0, and that's not where we want it. We do want this at row 2, and we have it here. The problem now is that we have some defaults we need to reset. That's it. We do want to extend that to the left and right. There. Now also, we do want to create rows here because I want there to be 2 rows, one for the output, one for the input. So let's do that. In our row definitions, let's add 1, 2 rows. The last row seems a bit too big. So what I want to do here is also restrict that to, let's say, a height of 0.25 star. How's that? Yeah. Great. Let's put 2 text boxes within this grid. Text box number 1 and text box number 2. There we go. So the first text box is, let's just rename this to output, or Python output. And the next one is, you guessed it, Python output. For the Python output, I want pretty much a black background. Let's just go ahead and put that to black. Let's also get rid of these defaults. And stretch it. And also, we want the second text box to be at row 2. Row 1, excuse me. There we go. Yeah, and this one also needs to stretch vertically. There we go. So now it's a little bit more Python-esque. And let's also stretch this one all the way. And let's get rid of the automatic default width and height. And also, I do not want a background that's white. So let's make it a first of all a foreground to be white because my background is going to be black. There we go. So now we have. So we need to get rid of the text box. Let's get rid of that one because we don't care about it. There we go. Great. So now we have a place where we can put our inputs and our outputs are going to go exactly here. Yeah, so the only thing I do not want to have the ability of this to be editable. So what I'm going to do instead is I'm going to say that that's going to be basically this is going to be is read only. I just want to set that to true. There. We also want the vertical bar visibility here, so vertical scroll bar, yeah, and we want that to be equal to also. There. That should be it. Let's run it. Nothing's going to happen because we haven't connected our view model to what we just built here. So let's do that next. The next thing to do is to edit our main view model. Let's go there. Now this part is going to be a bit difficult, so bear with me. I will try to explain everything. One of the first things I want to do is to add this reactive string builder, because that's going to keep up with the output text that's set here, and there's some reactive bindings there that make updating this console area straightforward. And how that's implemented is just as you can see, when we add a text to it, the raise and set of changes set for that text if it has changed, and that's going to basically refresh that area in the UI. So that's all you have to do to get that to display the text. So that's nice and convenient. So let's go ahead and add that reactive string builder, and let's call it the Python console text. And we also want to have a Python command that's going to basically, whenever we hit enter, that command is going to be executed. So for that we need a reactive command of unit, and we'll call this let's call it the Python command. Just a second. Python command. Right. And the last thing we need is for our main window, when something is typed here, I want that to be held somehow. So the way to do that is just for building another property, and this type is string, and we'll call it the Python code. Basically, it's whatever you type in. That's it. We do want to make this reactive as well, so let's make this into a property with Python field, and let's make this also a reactive. Raise and set if change ref, the value is in Python code, and then just value. That's it. Great. Now we just have to make sure that everything is initialized, so let's go and say initialize the Python string builder, so Python console text, so let's do a new string builder, and also we want to make sure that our command is initialized. So for that we have our Python command, and say reactive command, yes, and then we have create. Now we want to have a handler that is executed when we hit enter. So let's just say run Python command handler. That's going to take care of that. And this when any, and this is going to be a bit complicated, so bear with me. The new value of our string, in this case our property Python code, and then we also want to filter for that any s not s dot string dot is null or empty. Yes, great. And that's really it. I may have one too many parentheses here, but let's get rid of that later. And now let's create a private void. Here's your command handler. Okay, that's what we want. And what we want to do now is for the Python console text, which we have here, we want to add that, and we want to have the Python code added so we can display it on the output window. So once that's there, we also want to have run the command as well. So the command output is going to be captured by Python output. Let's just say out, and Python engine controller run command. Now, I said before in the beginning that we were going to go bottom up, and the controller was next in line after the modification to the Python engine. However, it turns out that I already had the run command there, so we don't need to modify the controller for now. So let's just go and give it the Python code that we want to run. And now the Python console text can simply just we can simply add the Python output. And that's it. Oh, we do want to clear it as well. So whenever we run some command here, after it has finished running, we do want to clear that so we can run the next command. And something very dumb but simple. Python code is equal to just string empty. We can just say string.empty. So that's it. And hopefully it builds. It should. So the next thing to do is now edit the main window.xaml.cs and connect the UI to the view models. And we'll do the reactive bindings there. So let's do that now. Now going over to the main window.xaml.cs, this is where the code behind is going to be modified so that the XAML and view model, or basically our UI and our view models, are talking to each other. So let's go ahead and do a bind from view model. And for the first property, I want to bind. It's going to be the Python code. So let's just go to Python code, and I want to bind that to the v, or in this case view. And let's say the Python input, I believe it's called. So basically that would be this guy right here. So we want to bind that to that. Yeah, and we also want to bind that to not just the input, but the text of the input. And that's it. So next thing, what we want to do is, maybe I should just make this full string. Yeah, that's better. More space. So now let's do another binding. So this time, this dot, we'll do a one-way bind this time. And then we're going to go again for the view model. And this time what I want to bind is the Python console text, exactly. And we also want to bind the text of that. Now remember, this is the reactive string builder. So we have a text there that changes every time that the output changes, or needs to change. So we also want to bind that to the views v.python output, and then we have a text property there. That's it. The next part is a bit long. We want to have the capability whenever we type something on the input to be we want to invoke that command. So the way I'm going to do that is by creating an observable. So bear with me with this one. So let's say observable, and then from event pattern, let's use the generic one. We want the key event handler, and of course we want our key event always. Yeah. So let's bind our inputs, and first thing we're going to do is just say the key down. So the Python input dot key down, and we're going to bind that to our event. And the reason why we're doing it this way, because it's just so much more convenient to have reactive events which clean themselves up, and you don't have to worry about disposing them manually, because you do have to unsubscribe from events whenever you subscribe to them, or else it's a memory leak. But reactive takes care of that for you. So let's do another one. So ev, let's see the Python input dot key down, and also unsubscribe to that. And that's going to be done for us automatically whenever this goes out of scope. So that's it, and we will do a select. this time we want to have the key event args passed in so that we can also filter for the enter key. So of course we need to do an where x.key, yes, and then we have equals, let's just say enter key dot enter, yes, great. And then we have another thing that we need to do. Whenever that's done, we need to, of course, as each enter key is pressed, we want that in our stream to appear as a unit, so, or basically a void. So let's just do a unit.default, and then we invoke the command for that, which is going to be in our view model. And view model has, of course, our command that we set there, which is just the Python command. There we go. And then, of course, if we want to have the nice capability of everything being disposed for us, we have to dispose it with the disposables, I believe what we called it. No, just disposables. So that's it. Phew. So after all that coding, we're finally ready to run the program. So let's go ahead and do that. Looks like I made a few mistakes. Buffer is not initialized. Sure, let's go ahead and fix that. ctor and buffer is equal to a new list. So that should take care of that at least. Let's run it again. And here we go. Great. Let's try to print something. It looks like we do have something that is trying to be printed, but we don't see anything. So let's check it out again. What's happening in our, let's see if we actually get something in our string builder. So this is the thing that's actually bound to the output. So if there's something here, then we should be able to see it. So let's try that again. Print a, do we have something? It looks like we have it. So this should be triggered and updated in the UI. We're not seeing that. You know what? Silly thing, let's check this. Let's see, we have a black background and a foreground that's black. That's not going to work. So let's change that. Completely white. Okay, let's try that again. So we should be able to at least see something now. Great, finally. And then maybe we can say sys.version. Great. So yeah, it seems to be working. So we have a way of now outputting Python information in our window here. So yeah, so now we're capturing standard output at least, because we can print something. So let's say we have, let's see if we can do standard error. So standard errors are thrown by exceptions. As you can see, we have an exception here, and let's see if we actually get something in our output window. Yes, so we also have exceptions. P is not defined, so great. So we have standard outputs and standard errors now in our window. Next up, let's talk about how we can actually debug Python code. The last thing I want to talk about is debugging Python in Visual Studio. For that, you'll need two things. The first thing is to make sure you download the Python debugging symbols, and next is the Python development. Let's go over that. First things first is the Python debugging symbols, which you can actually get from your Python installer. If you're installing Python for the first time, then you will go through the setup steps, but since I already have it installed, I'm going to go to Modify, Next, and you need to make sure that these two checkboxes are checked, and that's it. And the next thing you need to do is to make sure that the Python development is installed. For that, you need to go to your Visual Studio installer and make sure that this checkbox is checked. For that, you also need to make sure once those two are installed that you have in your path, at least in your local variables, that Python is installed or set as well in your path. So make sure that the root folder of Python is there. I have the scripts here, but you may not need it, and this should be the only thing that you need. Okay. Then furthermore, that's it. We are ready to debug Python itself. I'm going to clear this breakpoint, and then I'm just going to run the application without debugging first, because what we're going to do is attach. And the next thing I want to do first is let's not attach yet. Let's first run the script. I need to do this step, or else it's not going to pick it up. I think this is new. I didn't have to do that before, but now you first have to run the script in order for the debugger to pick it up. Let's attach. We want to attach to manage native in Python. I have a filter here which is going to filter my list of processes to the one I want, which is the PythonHospital demo. I'll attach. If everything is attached correctly, you should be getting this breakpoint with a solid red circle there, which means we are ready to attach. Let's open the script again, and we have a breakpoint hit. In our call stack, we can see that it is in our Python source at the moment, and then our main source is also shown. What's also interesting is that you can go to C# as well. So for example, here is C#, and you can see the entire stack trace where we are executing our Python source. We've reached the end of this video. I hope you have found it useful. It was meant to help you integrating PythonNet into your .NET application. If you still have questions, do leave them at the bottom. I will certainly take a look at them. So until next time.